All right, hey guys. I have the second half of the practice quiz here that I'm going to work through with you guys. Just a quick reminder too, those of you guys that have been out quarantined for quite a while now, what I am going to do for you guys is I'm going to give you this completed copy. I'm going to make copies of this. It'll be completely done for you. This is basically going to be a study guide for you guys as you kind of go through and prep for taking the quiz just like everyone else. You can see I have the first half done from Friday yet already, and then I'll fill this in and make copies for you guys. The people who've been in school are actually going to be doing their quiz or taking their quiz tomorrow. For those of you that come back tomorrow, what I think I'm going to do is I'm going to get you this practice quiz, and then I'm going to allow you to work on some catch-up work, the things that I've been submitting if you maybe haven't been getting them done or haven't been turning them in. For whatever reason, not able to get them loaded online or poor internet or whatever. But we will have to get you guys caught back up at some point here. So just kind of be aware of that. I think some of you are coming back tomorrow, and it'll be your first day back. So I won't obviously have you guys taking the quiz with your classmates, but I will have you guys working on some older stuff, and that should help prep for the quiz too. So with that being said, we'll just kind of dive into this. Number 9 says write an inequality for the following statement and then solve that inequality. So it's pretty standard stuff, just turning word problem into the actual expression. So it says 15 less than, we're going to chop it off right there. To get 15 less than something, this is when less than means subtraction. Notice it doesn't say 15 is less than something. That would be an inequality, okay? So 15 less than something is accomplished by subtracting 15 from it. So we have to finish this subtraction. On the other side, it does say the product. So over here, I need to put a multiplication dot. The product of 2 and x, a number x. So it's product of 2 and x. So in reality, we could have just wrote this as 2x minus 15. And then here it does say is less than 31. So I like that this problem gives you both versions of less than. It gives you the less than that means subtraction, but it gives you also the less than that means less than, okay? So like I said, 2x minus 15 is less than 31, and then all we had to do was solve from there. So we're going to add 15 to both sides. We get 2x is less than 46, divide by 2, x is less than 23. All right. Number 10 is a rate of change problem. It says the table shows the distance traveled by a car after each time given in minutes. Find the rate of change in distance for the car. So the fact that it doesn't give us like an interval, it doesn't say find the rate of change from 15 to 30 or 30 to 45. That just means go from the beginning information to the end information. I'm going to compare those two. I'm going to remind you of some stuff that we worked with early on before anybody got sent home. Rate of change is basically just slope, but we don't think about it in terms of what we usually think of slope as. Slope is usually rise over run, or y2 minus y1 over x2 minus x1. Here we think about it as change in what's called our dependent variable over change in our independent variable. Okay, change in dependent versus change in independent. So the first thing that we need to do is we need to label the dependent and the independent variable. Okay, so it goes back to which one of these determines the other one. Does time determine distance, or does distance determine time? So one of the things we've kind of said all along is that time is always independent. You can't adjust time. You can adjust your distance, okay, that you've traveled, but you cannot adjust time. Time is independent of all other forces. So time is always independent. Whoops, it's supposed to say time there. Time is always independent, which means that distance, in this instance, is our dependent variable. So it's the change in the dependent variable, which is the change in distance. So from 20 to 60, we can just use 60 minus 20. And then put that over the change in the independent variable. So time is 45 minus 15. We get 40 over 30. And one of the things that's very different about rate of change compared to slope in terms of how we do it is if this were slope, we'd leave it as 4/3. We'd leave it as a simplified fraction. But it's not. Okay? It's rate of change. So we do the division. 40 divided by 30 is 1.6 repeating, so I'm going to round this to 1.67, 2 decimal places. We turn this into a single number by dividing so that we can label it. It's miles over minutes. So we say it's 1.67 miles per minute is the speed or the rate of change at which this car is moving. So they're changing 1.67 miles per minute. Okay, that's the only rate of change problem on this practice quiz. Then we get into, for the next several problems here, we get into the generic stuff. We get into, finding slope between 2 points. That's what 11 and 12 are all about. So 11 is finding slope between those 2 points. So it's y2 minus y1 over x2 minus x1. And like I said, I'm pretty sure everybody was here when we were going through our slope stuff. Okay, so the difference in the y's is this, 15 minus 6. 15 minus 6, and the x's on bottom is 1 and negative 2. So 1 minus negative 2. We've got to be careful with our subtraction, our double negatives, stuff like that. So on top, 15 minus 6 is 9. Double negatives go to positives, you get 3. 9 divides by 3 perfectly. Okay? And then it's the exact same thing on number 12. On number 12, we're going to find our slope by doing change in y's. The y coordinates are negative 2 and 4, so it's negative 2 minus 4. And then put that over the x's. 1.5 minus negative 2.5. So again, we get double negatives on the bottom, so we add them. It ends up being 4, and then negative 2 minus 4 is negative 6. So we have a negative slope this time, and we're going to simplify 6 over 4 by dividing by 2. You get negative 3/2 for our slope between those 2 points. All right. For 13, it's again a slope problem, but this time we have the picture to go off of. So anytime we have a picture, anytime we're graphing at all, we don't think about the slope function. We think about just rise over run. Okay. So obviously the only thing that we need on here, the only thing that's missing would be having the 2 points. There's a point, there's a point right there. And then from the left point to the right point, all we do is calculate rise and run, counting rise and run. So from there to there, we go down 1. So I have a rise of negative 1, and then I run 2. So it's a negative 1 over 2. And then when we're actually just writing that, we write it as just the fraction negative 1/2. Okay? So pretty simple, pretty straightforward for 11, 12, and 13. 14 is when they get into and they want us to write an equation. So it says write an equation. It should say in slope-intercept form for the line with the slope of 2/3 that passes through this point. So what this brings up, and it's actually pretty convenient that it does this, it gives us slope and a point. So what I told everybody in class today is this formula will be on the board for the test. Okay? That is the formula, like we've seen, for point-slope form of an equation. Again, point-slope form. You have both of those in this problem, so those 3 numbers, 2/3, 3, and negative 4, get plugged directly into this formula, where obviously m stands for slope, so 2/3 goes right there. Okay, every equation's got to have an x and a y, but then what we do with these 2 points, it's the opposite of the x coordinate. So my x coordinate in this point is 3, so I got to put minus 3 right there. And then after the letter y is the opposite of the y coordinate. So this is where my y coordinate's negative 4. The opposite of negative 4 is positive 4. So what we do is we plug that in, and then basically from there we just simplify. We distribute 2/3 to get rid of the parentheses, so we get 2/3 x. 2/3 times negative 3 is obviously a negative. If you pull that off to the side, 2/3 times 3 over 1, the 3's cross cancel, and you're left with just 2 over 1. So that's just 2 right there. The last thing that we would do to both sides here is subtract 4 from both sides to get y by itself, which is what slope-intercept form is going to look like. So at that point, the 4's cancel, y's by itself. We bring down our 2/3 x, and then negative 2 minus 4 is negative 6. There is an equation in slope-intercept form. But again, we got to it by plugging in the point and the slope into point slope form, okay? Number 15 is going to be incredibly similar to number 14. Number 15 says write an equation in slope-intercept form, same as it did up there, but here they give you the pair of points, okay? So in order to do this one, we have to first calculate slope the same way we did on 11 and 12 up here. We do y2 minus y1 over x2 minus x1. Now I'm going to just tell you guys right now, I'm going to run out of room here if I don't. So I'm not going to show the work, I'm just going to tell you what it comes out to be. It ends up being a slope of 2 when you do the subtraction of the y's and the subtraction of the x's, okay? So from here, I have my slope, I pick a point, and I do exactly what we just did on that last one. You plug in, it's always the letter y followed by the opposite of the y coordinate. So the opposite of 3.6 is negative 3.6. Then it's equals our slope, so equals 2, and then in parentheses, it's the letter x followed by the opposite of your x, so minus 4.2. And then from there, same exact steps that we had up here. Distribute, you get 2x minus 8.4 equals y minus 3.6. I'm going to add 3.6 to both sides. We get y equals 2x minus 4.8. There's slope-intercept equation. Okay, we're not going to have room, so I'm just going to get rid of 16 here. 16 is a super simple one, so it's not a really big deal. But I definitely want to make sure that we spend some time talking about 17, 18, 19, and 20 here real quick, okay? 17 and 18, I'm going to graph both of these on the same thing. So basically, hopefully you've been kind of following along with the videos recently and you're getting the instruction at home, because we have been looking at a large amount of review of graphing linear equations, okay? So graphing these two inequalities is no different than graphing a regular equation. This one, number 17, is pretty nice because it starts out in slope-intercept form. Y is less than or equal to 3x minus 2. So it starts out by giving us our y-intercept. We get this for free. Negative 2 is where this one crosses the y-axis. So right there. And then to get to our slope, just like up here, we counted rise and run. We're going to count rise and run here. The rise is 3, the run is 1. So from here, from this point, count up 3 over 1, rise 3, run 1, and that'll give you your second point. The thing we have to remember with inequalities is sometimes it's a solid line and sometimes it's a dashed line. What makes this one solid is the equal sign underneath the less than symbol. And then we also have to shade. Our solutions are not just the points on the line, it's the points either above or below the line. So less than means below, so we shade everything below that line. Okay? 18, same concept, different work though, because 18 does not start out in slope-intercept form. Excuse me. So we have to convert. We have to get the y by itself in order for this to be in slope-intercept form. So a little bit different method here. We have to start by moving the x, okay, just like we've been doing recently. So we subtract the 3x to move it to the other side. That makes the negative 3x comes down first, positive 12 comes down second, and then we divide everything by 6. Divide by 6 there, that gets y by itself, which is what it needs to be. Divide this whole side by 6, and then split apart your compound fraction. Negative 3 over 6 simplifies to negative 1/2. You can kind of pull the x out after it. And then positive 12 divided by 6 is positive 2. At this point, then, that one is in slope-intercept form and can be graphed the same way we graphed this one. This one's got a y-intercept of positive 2, so that'd be up here, and a slope of negative 1/2. So a negative slope just means we go down. So I go down 1 over 2, gets me right there. There's my 2 dots. This time, though, there's no equal sign, so this is going to be a dashed line. And greater than means you shade above. So there would be your shading on that one. When it comes time for you guys to take the quiz, I'll make sure there's graph paper on the quiz and you'll only be graphing one inequality per. All right, we're just about out of room. We have just enough room to finish off number 19 and 20. 19 says, is the point -1, 5 in the solution set of this inequality? Y is greater than 3x plus 8. So there's two options here. You could graph this, right? Greater than 3x plus 8, that's in slope-intercept form. So you could draw the line, make it dotted, and then shade above it, and then see if this point is in that shaded area. But the more direct way to go about this is just to plug it in. If it's a solution, it should plug back in and check out. So plug in -1 for that x right there. So 3x plus 8, plug in -1. And plug in for the y, 5. And then check to see if it tests out. Well, this is kind of weird because 3 times -1 is -3. -3 plus 8 is 5. And then the question just becomes, does that make sense? Both sides are equal, but should both sides be equal? And the answer is no. The left-hand side should be larger than the right-hand side. Okay? And I'm going to wrap this up here. We're already over 15 minutes, so I'm going to wrap it up real quickly with the number 20. It says, what is the boundary line of the graph of that equation? Is it solid or dashed? Well, you can see there's an equal sign there, so it's definitely a solid line. And this one's just worded kind of strange, but all they're really asking you to do is identify the slope-intercept equation of the line. So we do kind of the same thing we did on number 18. We're going to subtract the 5x, subtract 5x. That moves the 5x to the other side, so we get 2y is less than or equal to 3x minus 5x is -2x. Bring down your -4, and then divide everything by 2, which works out nicely because everything is divisible by 2. You get y is less than or equal to -2x divided by 2 is -1x, and then -4 divided by -2, or excuse me, -4 divided by 2 is -2. So there's the inequality or the equation for the boundary line. All right. So again, this video was really just to give you guys kind of a general sense, something to follow along with, so you're still kind of keeping up a little bit. But ultimately, you'll get this study guide to study from. Hopefully, you guys are all able to be here tomorrow, and we can start the process of getting you guys caught back up. Okay. So that'll do it for today. Nothing necessarily you guys got to work on, but for those of you that are behind on some assignments, try and get those at least done. That way, they can be submitted once you get here. So. All right, guys, take care. Talk to you tomorrow, hopefully.